Hi. So you want to find out about pretty easy privacy? That's good because I wanted to tell you about this. Here you find mail and Twitter and these things. Pretty Easy Privacy is a project that stands at the very beginning still of rolling out mass encryption. That's our goal. We also brought some stickers. They've been at the main entrance. I don't know if there are any left, but I really like this mass encryption hashtag. So as you might have guessed, it comes from PGP, Pretty Good Privacy. Who knows about PGP? I guess here it should be everyone. Who's using it? Who's using it daily? There you see. So this was not even half of the ones who are using it. And also just, I say 2/3 of the ones who know about it who are actually using it. So this is what we're trying to do. And another question in this context, who was trying to roll out PGP in a company or in a, let's say, organizational environment? Okay, just a few. And did it work? Yes? No? Okay. So it was 3, 1 worked, 2 didn't. So, all right. So you see, this is really a problem still, and it's actually unbelievable because we all have those messengers today and we all feel like, okay, we can encrypt everything, but we cannot encrypt email, which is still the thing we're using the most. But okay, I'm trying to tell you how we're going to solve this problem. I have 4 chapters. The first is an introduction. Then I tell you about the technology for mass encryption, and then the general concept of PEP that also includes mass metadata protection, which I'll explain in the last chapter, which I also do a lightning talk about it. So let's see how much time we have left. Maybe I skip this and you, if you're interested, you check out the lightning talk. And then I was told there's another talk later not happening, so I hope we still have enough time for Q&A because we can actually go a bit longer. We're already late in schedule, you have realized that. Yeah, and interrupt me with questions anytime, especially if I'm talking too fast. All right, so motivation, Declaration of Human Rights, Article 12 tells us that we have the right to protection of the law against arbitrary interference with privacy, family, home, or correspondence. As we know, this isn't the case. This is a quote, I read it out loud. I don't want to live in a world where everything that I say, everything I do, everyone I talk to, every expression of creativity or love or friendship is recorded. This is what Edward Snowden said and what he showed us, that the world we're living in is like this right now, because the governments are doing the opposite. They're not protecting us with the law. They're getting all details of our life, even on like special requests, if you want to. This is one of the thousands or even millions or billions of slides which he leaked more than 5 years back. It's quite a while back. So we have this problem, and we also have this problem, that we are scanned and profiled everywhere, and that actually if you're not paying for it, you're not the customer, you're the product being sold. So the problem is that online communication is visible like a postcard, and that this world has mass surveillance, and the solution we're trying to follow is right now to make mass encryption and then add mass anonymization, like full metadata protection on it. So yeah, Pretty Easy Privacy does what the user would want to do. We're coming from this crypto party background, teaching people, and we were just saying, okay, instead of writing how-to guides, we write user expectations into software and protocols to automatize all steps a user would need to carry out. The idea is to take away the crypto needs from the user's view, like it happened with HTTPS after Snowden, quite invisible, but it didn't happen with email. And this is what we're trying to do. So how do we do this? We wrote an RFC or an internet draft. That's the first step of an RFC. You know how these looks like. This is the URL. We did this together with the ISOC Switzerland, and we wrote down the general PEP principles. It's online and there and ready for discussion. And also we did write software. I'm coming to this later, but this is the main core of the thing, because the software we're writing so far only makes email, but not mass encryption. But email is the one we were focusing on. So this is the abstract. I read out the underlined parts. Building on already available security formats and message transports, Pretty Easy Privacy describes protocols to automatize operations, key management, key discovery, private key handling, that have been seen to be the barriers to deployment of end-to-end secure interpersonal messaging. So that's what's PEP doing. And what does the user do? Writing messages, ideally in whatever format. Again, we're on email right now, but we want to have this for all written communication. So this is how it looks like today. We have 2 users, one of them installing PEP, the other one could also be a normal GPG, PGP user, but in this case, both users installing PEP. Then Alice writes an email to Bob, which is now unencrypted postcard, but this one already has the key attached, because in this step, the key gets generated. The user doesn't get to know about this at all. So here, the key gets attached, and now Bob replies back to Alice. It's not so easy on this angle. Bob replies back to Alice, and this email now is encrypted. So from this point on, Alice and Bob are in an encrypted channel. So they can continue writing, but as usual, they should also verify their trust. So we translate fingerprints into trust words. So Alice and Bob call each other, read out loud correct horse battery staple. The software makes a handshake, and now they're encrypted and verified. This is the same thing on one slide. So Alice writes to Bob the unencrypted postcard. Bob replies back, it's already encrypted. In this modus, they can stay if they like. I mean, we all do this, right? On Jabber with OTR and everything. It's like fingerprints, yes, yes, okay. But it's always about the threat model, right? And we are not focusing here on the people who have serious threat models. We're focusing on the masses. That's also why the user doesn't even get to know about a key. Some of you were like, oh my God, but what about the passphrase? What about the hardware is affected and whatnot? But then we cannot solve everything. If we put a passphrase on it, then users will run away right ahead. So we need to make it easy. And if someone really has a threat, then use something proper. That's also something we don't want to replace any of existing tools. We just want to be compatible, and we want to make it usable for the masses who don't want to care about how to use their computer and how to use encryption. They shall care about the environment and about our kids and about that the world doesn't break down, and they shall not spend time on learning these things. So this is the modus. They can stay if they like, but then they should definitely call each other, and we're trying to communicate this as much as possible, as well as we're also saying that full disk encryption should be done. So we're not having a passphrase on the key, but then we're telling the people to keep their systems up to date and to make full disk encryption, because that doesn't disturb them in their daily communication. Yeah, and then they're again like on the secure and trusted channel. So what is PEP? I said some of the things already. Software for various platforms to easily use existing crypto tools like GNU-PG. Pretty easy. Designed to encrypt all digital written communication with the starting point of email, privacy by default. PEP encrypts automatically with whatever most privacy-enhancing crypto standard available. So we're following the opportunistic approach here. All end-user software must be hassle-free and zero-touch. That's why no passphrase. What is PEP not? Not yet another crypto tool with a closed user base. Not any even centralized platform provider, not implementing any own crypto, not replacing any existing crypto tool per se, and not just an email encryption tool. That's just the beginning. And then, always important in these kinds of projects, like who is PEP? We see ourselves as cypherpunks. We want to roll out mass encryption to optimize the costs of mass surveillance. We know that we're not going to stop it that way. We want to make the use of crypto pretty easy. The developer shall just plug it in. The user shall just use it by default. How this plugin works, I'll explain in the tech chapter. What cypherpunks? I guess in this round, it should be fairly known. I actively engaged in making the network safer, following a route to social and political change. This is from the Cypherpunk Manifesto. I read out the middle part because I find it actually very important, especially out there when people are like, oh, but I don't have anything to hide, my privacy is not so important, and go to hell with your privacy, like la la la. Privacy is not secrecy. A private matter is something one doesn't want the whole world to know, but a secret matter is something one doesn't want anybody to know. So, and then last part from the Cypherpunk Manifesto from 1993. We cannot expect governments, corporations, and other laws-faceless organizations to grant us privacy. As some of them are here, we're not expecting you, but we would be very surprised, like positively surprised, if you would be doing something into that direction. Thank you. We must defend our own privacy if we expect to have any. We know that someone has to write software to defend privacy, and we're going to write it. So this is who we are. And now, last slide in this chapter, like who is SWA? I'm originally coming from the humanities. I also studied computer science and learned to build furniture. I'm involved in various projects and especially events. Refounded Crypto Party in 2013, shortly before Snowden happened. That was just coincidence. And organized lots of events for German CCC and also in India, Hillhacks and Hackbeach. SWA I use as a unique addressing for internet and web. If you want to know my real name, you can check out the board members of Chaos Computer Club or Hackers Without Borders. You find one female name, which is mine. All right, so let's finally step into this. This is now 8 chapters. I explain the architecture, which consists of engine, adapter, and applications. I show you some repositories, development platforms, and also our organizational forms. Some of you might know we have a company in Luxembourg, but I'm from the foundation in Switzerland. So this might sound weird, but I'll explain it in that chapter as well, because it's also quite a hack to use those different entities in a way that it all works out. And then I make a little excursus. Our first challenge we had last week. Maybe someone followed it in the media. Did anyone? Okay, great. So we actually did a good job. That's good. But now you all gonna know, like we're blaming ourselves. But that's nice. All right, architecture. We have this architecture of an engine, adapters, and the actual apps, which can also be just plug-in and stuff like existing apps who are plugging in the crypto functionalities that way. So these, apps are for the actual usage, like sending messages. The adapters exist in various languages to plug in the engine into those applications. The engine has an API and is serving all the crypto and key management functions and knows about the various transport protocols. I come to this into more detail. On the right, there's an example. I think you can see it yourself, like with an Outlook plugin, which needs the COM server adapter to plug in the engine, or Enigmail, which needs the JSON adapter to plug in the engine. Here are some more examples. There's an Android app which needs the JNI adapter to plug in the engine, and an iOS which uses the Objective-C Qt adapter to plug in the engine. I think you got the concept. So the idea is that the developers who are having, let's say you're having a plain SMS app on Android, and you made this, you're selling this on the Google Store, and you heard about this encryption thing. And you said, okay, let's sit down and let's read about it a bit. And then you figure, okay, this is not as easy as I expected. And you give up. So that's the moment where they should get to know about PEP and say, okay, great. All I need to do is I need to interface my application with the JNI adapter. And then I get crypto. Like whatever magic's happening, I don't know, because I trust those guys. I come into this more detail what the engine is about. So the engine drives several crypto standards on different digital channels, like message transport protocols. It's written in C99. I think it's meanwhile a bit more than 10,000 lines of code. I forgot to look this up. And has regular code audits, as in we have a process of making regular code audits. There's one yet. It's not meant to be used in the application code directly. As a developer, you can just plug and play the engine, which means you don't have to maintain the crypto. So now it's like, okay, what? We make those code audits, and we're trying to be as transparent as possible. Everything is online. We do live coding online. So the repositories are online. It's not that we put a copy of our working repositories sometimes public. Everything is public right ahead. So we hope that people who don't want to dive into security and encryption are fine enough with this process. So the engine takes care of the messaging functions, the crypto text services, the fully automated key management services, the trust rating, and it knows about the transport protocols, the message transports. In the future, it gets to know about this metadata protection via GNU-net, formerly known as anonymization. But metadata protection sounds better, doesn't it? So the engine does the decryption and encryption, the encoding and decoding of MIME, message processing for the adapter, key management, which means generation, verification, blacklisting, also like key reset if your key expires or something. Key synchronization of same account between devices. This is not ready yet. It is ready, but it's not rolled out. This is what we're really looking forward to, but I have another slide on this later. The adapter, which plugs in the engine, is a language or environment-specific interface between the engine API and an application development environment, which can be a programming language or an IDE or something. The adapter basically serves bindings to fulfill whatever you want to do. So these are the 6 adapters we have more or less in production. They're ready. They're not very well documented yet, but they're still somewhat ready to use. But then, like, not really plug and play yet. But as I said, we're still at the very beginning. The app makes calls to the adapter for the function it wants, which can be encrypt, decrypt, encode, getting the trust words, verifying identity, decide on the trust level on the identity or on a particular message. And the adapter converts that into a normalized standardized form for the engine for messages and makes the C library call. Then the engine magic happens and the adapter gives the result back to the application. So this is how it basically works. And this is now the app layer. So this is the current implementation we have. It so far handles OpenPGP without hassle for the user. As said, this is just the proof of concept. We want the engine to know about more crypto techniques and more message transport protocols. It automatically encrypts. It encrypts the subject inline. It makes the automatic key management. There's no key server or any other centralized infrastructure needed. So we do attach the key. And PEP knows about attached keys. So if you are a GPG user and you want to write to a PEP user, you need to attach your key. That's what you need to know. And then the PEP user doesn't need to know about it. But if you send the PEP user an URL with your key, then the PEP user is like, oh, what shall I do? So just attach the key. We translate fingerprints into trust words to make them easier to read. We have an opt-in passphrase for keys. I already explained that, I guess. We have an import for existing keys. This is new. This came with the second last version or something. We have this force protection mode, which I find very interesting. So, for example, if you're a lawyer or a doctor and you want to send out stuff to your clients and they don't use encryption, which usually would be the case, right? But you feel like, okay, I cannot send this out unencrypted. So you can send it out, make a force encryption thing, which means the client gets an email saying, you got an encrypted email. Please go here and install, for example, the Outlook reader, which is then only a reader, which doesn't cost anything. or if you're like depending on the system, you can install Thunderbird or whatnot, and then you can read this email, and you had to get a password from your doctor or lawyer or whatever. So then the lawyer can make this force encryption to his client, and the client can unlock these emails with the help of the PEP reader and a password or a Thunderbird or anything else. Then there's a passive mode. I use this, for example, on my phone. I don't want to have my CCC keys in, so my CCC accounts, like mail accounts, are in the passive mode, so that there I'm still on the, oh, sorry, I'm on the road, I cannot reply to your encrypted email thing. But with other accounts, I'm already fully functional, and I can read and type encrypted emails, which I can really type on my phone. Then we have this Outlook disclaimer function. So we are all geeks, so we didn't know about this. We just found out by testing that Outlook has a disclaimer, which apparently the Exchange server attaches after sending the email out from Outlook. So now our Outlook plugin made the email encrypted nicely, everything fine, and now Exchange, bam, attached the disclaimer. If you're not the one who should read the email, please throw it away disclaimer thing, right? So this broke the whole encryption, because then it couldn't be decrypted and whatnot. So now we fixed that, so you can still have your disclaimer if you really need this. The header gets encrypted and obfuscated as much as possible. This we do, like we wrap the email like a forward and put in another header on top. This is a point where we are trying hard to stay compatible with AutoCrypt. You might have heard about AutoCrypt. It's a similar approach, and they're working very heavily with the header instead. And we are saying, no, header is also privacy leak, so we shouldn't use it. And they're like, okay, header is great. We can use it for attaching keys and whatnot. So there we are a little bit, but we're trying to stay compatible as much as possible. And then we have this PepSync protocol, which is not there, but I still have a slide where I explain this. What is there is this Outlook add-in, it's called. There's an Android application, there's Thunderbird for Linux, Mac OS, and Windows systems. There is PEP for iOS, very alpha, but if you want, you can test. I think on PEP Foundation /blog, there was a blog post recently how to contact and be part of the testing. And yeah, more to come. What we definitely need is browser plugins, because that's the reality out there. But then we also need the different message transports as well. So these are the repos for the applications, for the app ones. You can see already that I also highlighted it, that the domains are very different. So I already told you that we have a very weird construct of different entities, which I'll explain pretty soon. So Android, Outlook, and iOS are done by the PEP security company here in Luxembourg. Enigmail is on SourceForge, because Enigmail always was on SourceForge. And this is just a community joint project, like the PEP Foundation does this together with the Enigmail developers. And then we have on PEP Foundation /dev, we have the engine and the adapters and some MISC, because the idea is that the code always belongs to the foundation. Like, not the application code, but the code of adapter and engine. Application, if you're the one having an app and you want to plug in PEP, the application still belongs to you. But the engine and the adapter always stays at the foundation, which means it always stays free. It will never be part of any kind of commercial confusion. It always stays free. And then on PEP Foundation /PEP software and on pep.software, we were trying to collect everything. This is how that looks like. The left is the post on the foundation site. And the right is pep.software, where you can download binaries. This is the main point. But then I also highlighted the lower part, like you can open this up, and then we're trying to fill this. It's not all pretty good filled, but that's the approach we have, that you're not only getting the binaries, you also get the sources, and you get the code audits, and you get reproducible builds and everything. And this is then the actual repository where we have engine adapters and, as I said, MISC. So you can take a look yourself. This is the list again, a little bit more readable. You can see, for example, also the internet drafts we were writing in there. We have this, JML stuff, like everything we need, or packages, the documentation for packages within PEP software is done there. But yeah, I should go on. Developing platforms, we're developing on everything, which is quite fun in the office, having all those different cultures sitting together, especially as we are still a very small team. So we have the BSD guy sitting next to the Linux guy, but then there's even the Windows guys next to it. So this is really fun. And here we come to the organizational forms. So we have the pep.security, which is a normal company. It's Luxembourg-based. It's a SA. It's selling the applications and the plugins and the additional services. This company has investor money. It also gets funded from the government of Luxembourg for some IT startup, this thing. And the main guy there is a guy from Luxembourg. That's why it is sitting in Luxembourg. Then we have the foundation, which is generally supporting free software. And as I said before, it's mainly there that the code belongs to the foundation. They're very thick contracts between the foundation and the company, because the company mainly produces code at the moment, which then belongs to the foundation still. And there the main guy is Swiss. That's why it's sitting in Switzerland. I know that it looks weird when you have a foundation in Switzerland and a company in Luxembourg, but this is the main reason, because we are people from Luxembourg and we're people from Switzerland. And then we just recently founded another piece, which is the cooperative. It's about bringing people together. You can get a member there. It's been founded by a bunch of artists and other, let's say, mid-famous internet activists and these things. It's there for cooperation with other projects to get members and to bring the people together, and then also to make web plugins. Because web plugins, we cannot ask any investor to give us money to make web plugins for free. So this is a problem. But if we want to reach the masses, we need to get our hands dirty and dive into web. So that's what the cooperative is there for as well. As you might see, we decided to go this top-level domain structure, so pep.security, pep.foundation, pep.coop, which we are then also trying to bring the stuff together, pep.software, I already showed it. Then we have pep.community, which so far only has a forum, but shall get mailing lists and chat and stuff, and then also pep.news, which isn't online there. But that's we had really a challenge to bring this all together, because at the end the user doesn't matter, doesn't care at all. Is this a foundation? Is this a company? It doesn't matter. I just want to install software. So, and now the other challenge I was saying in the overview, that we had another challenge to fulfill last week, which is this one. It actually wasn't a bug. It was a mistake in building a new version. And I'm sure this is not our first bug. I mean, look at the bug tracker. There are lots of bugs. But yeah, I found this still very nice. I tell you the story now in more detail. So as said, it was not a bug per se. There was never any problem with any of the application code itself, nor with the engine or the adapter code. It was a build error in the Windows version of Enigmail PEP, which is a joint community project. I already explained that. And it was simply caused by human error. So what you need to know, the PEP distribution 1.0.23 delivered on Windows comes with a DLL file for libadpan, which in turn depends on the libconf library. And that one wasn't linked in. So we were just so stupid to forgot to build this library into the libadpan DLL, which induced undefined behavior. It caused libadpan eventually to return with out-of-memory errors, and then the PEP JSON adapter it's just like went crazy, and then it resulted in messages not being encrypted. So this is horrible because this is the main function of our plugin, right? So one of the reasons is, the lack of testing processes, proper testing processes. Actually, it passed all our tests, which is weird, but let's not talk about this in too much detail. And also it's due to a lack of error handling towards PEP, which we had already addressed and which we are addressing heavily now. There's a ticket on SourceForge. It's ticket 909. Regarding the testing, it's like we have this joint project between our testing and the Enigmail testing, which has this like community testing, and this like dug us a hole we just fell into. We have very rare resources in this community project, and so on 26th of September, we made that build, and we published it, and the encryption failed. According to the figures from Patrick Brunswick, the main developer of Enigmail, there were 6,000 downloads between September 26th and October 3rd when we rolled it back. So a maximum, of 6,000 users downloaded during those few days. Oops, the faulty version. That's not even 2% of all Enigmail PEP users, and Linux and macOS were not affected, and also no product of the PEP security SA Luxembourg was affected. Yeah. And then this is the timeline. What happened one after another. So we've been contacted shortly before publishing. They published on 3rd of October. At the same day, we wrote a blog post blaming ourselves guilty and apologized and provided a workaround. We added updates there whenever there were any. They then also updated their article once we had a quick fix. On October 12th, we released a new version, and October 16th, they wrote another article. We also communicated wherever we could the updates in the comments and the forums of this article itself, on Twitter, IRC, mail, and interacted everywhere and with everyone who wanted to interact with us. Yeah, so these are some screenshots. This is the original article as it came on 3rd of October. This is our blog post on it with all the updates and some screenshots what to do, like how to fix it if you're affected. Then Heise in the afternoon directly also made the update pointing on the workarounds. And then we published a new release and a summary wrap-up in our blog, and Heise also published their article on their magazine. Yeah, that's what happened. And yeah, I'm glad that actually no one of you even got to know about this. So now you know, and have fun with it. Literally, because it is like funny. You can really laugh at us. So now into the concept. This is 6 pieces plus a summary. I go to this very fast because I think most of it I already said. This we already had as well. And the easy thing, not easy for users, but also easy for app developers. This is the trust words. We already talked about this. Then now we have the key sync. So this is part of the easy, right? It's easier to explain it like here. This is the slide I've been talking so often that we're going to be there at one point. So what we do is we sync via IMAP. So we use email as a transport protocol for syncing keys and also contacts and calendar if you want to. So we have a PEP user who installs PEP on a second device. Now, the new device pings the old devices. The user verifies with the existing device, also using the trust word thing. The devices exchange their secret keys and agree on a secret main key. So that's basically how it works. If that all works as we want to have it, this means you're syncing with your own devices and not in the cloud anymore, because the cloud is nothing than others, people's computers. So now you're syncing with your own computers. Yeah, this will be really great once it works. Then the general concept, we're trying to do everything right without compromise, end-to-end encryption, peer-to-peer transport, no centralized infrastructure, nor closed services. PEP is free software. That's sure, if it's about crypto, it has to be free software. Also, if it wouldn't be, we wouldn't be there, because of our mindset. We want to support multiple crypto technologies, multiple message transports, platforms, languages. This is what we support right now, the bolded ones, and the rest is about to come. But let's see how it changes. I mean, 2 or 3 years back, no one would have written down a memo here. These are the transport protocols we support right now and which we are looking at for the future. And then we have this major problem about the metadata protection. So this was now all about mass encryption. You know that content encryption is not everything. I guess in this audience, I don't have to explain what's the problem with our internet. It's just like leaking like crazy everywhere. We have centralized components way too much. And so there's this thing called GNU-net, which started in academia in the early 2000s. So it's now like 15 years old. It's been followed on various universities, departments, and research groups. The general idea is that the internet was founded in the 70s, and everyone was like, okay, great. I can access your computer and you can check out mine, right? This is awesome. Nowadays, we're like, sure, I can access other computers and use their services, but wait, what? They can also go on mine. And this is what you guys know, but people out there mostly don't. This is how I start crypto parties. If you are connected to the internet is connected to you. So what we need is end-to-end encryption and anonymization of the way data flows. And this is now part of the concept, and now I have another 5 minutes to actually go into more detail of GNU-net. So to summarize the concept, it's that users don't have to think about the crypto anymore. They can just use it by default. A journalist wrote once, it's this little hacker inside that decides on the cryptography chosen to communicate with the message recipient. So you know this from your daily life. You chat in someone's IRC in the channel, it gets you like too personal, you go into a query. You start OTR in the query, your partner doesn't have OTR on IRC, so you're like, okay, do you have Jabber? Okay, but then we can right ahead use Omemo. This is stuff you just do naturally, but we cannot expect this from the people out there. So we want the PEP engine doing all these decisions. All right, GNU-net, let's make a GNU one because you broke the internet. GNU-net is a mesh routing layer for end-to-end encrypted networking and a framework for distributed applications designed to replace the old insecure internet protocol stack. So to explain how it works or how it's supposed to work, I made this very hard simplified version of the internet and put another very hard simplified version of the GNU-net next to it. So we start with the physical layer where we just use all the protocols we already have and put on unreliable out-of-order packet delivery semantics and have this automated transport selection that decides which protocol to use. So there's no use on actually digging new wires and these things. But still, it's very important to follow stuff like Freifunk and like independent networks still. Sure. The next, like the Ethernet layer, is called Core, where GNU-net runs effectively an off-the-record link encryption between the peers. It multiplexes the messages to the higher level subsystems, and it hides connections to the ones who don't speak the same language. So this is, like the Ethernet, where today you can fake and spoof addresses as you like, and you can listen to communication, and that's then not possible, but I think I should go faster. This layer is about decentralized routing. It's an R5N, so it's a routing algorithm that's decentralized. And this is the heart. This is the transport layer. It's similar to the SCTP, the Stream Control Transmission Protocol, and serves end-to-end encryption. For additional services, there is Xolotl needed, which is a mixture of Sphinx and Axolotl for protecting metadata. And there is something called Lake, which is a further development of Pond to provide mailboxes and asynchronous delivery. All right, so if you're just like, okay, what is she talking about? By all science and mathematics we know today, all the metadata will be gone that way. Then we have GNS. This is easy. It's the GNU name system, which serves a secure and decentralized name system, no central root authorities, and provides an alternative PKI, and is interoperable with DNS and has query and response privacy. And then we have applications. There is definitely file sharing. What would be the internet without file sharing? It actually started as a file sharing project. There's SecuShare for all the people who say, I go to the internet, actually just mean the web, and usually just one web browser, one website. There's a thing called Conversation, which makes voice over IP and not conversations like the Jabber client. There's PEP for messaging and Thaler for payments, and you can start thinking about your apps in this Internet 2.0 if you want to. I skipped this. You can read it on the website, but what I have for this, you shall definitely check it out. There is only a release from 2014, so don't use the release in your packet manager or something. Please download the pre-release from June this year. And the installation guide is still valid, and we are about to set up gnunet.org/tutorial to make, because we have now a tutorial which even works for Ubuntu users who just copy and paste blindly commands. They don't even know what it's about, and at the end they have GNUnet running. So we're definitely at this point now where we should run it, where we should be nodes in the GNUnet, and where we should find all the bugs, because yes, they exist. It's an academic project. That's how the code looks like. And but my belief is that this is the only solution where, like, we're not gonna get solved. We're not solving all the problems out there we have in the internet. Like, what we do is we're fighting all the symptoms. But this is finally an approach to start at the roots of it. Okay, I'm nearly done. I just want to leave you this, that there should be a protection of the law, and that the government doesn't help us here, and that we should really continue relying on the law of mathematics. All right, because they are very commendable and they always apply. Thank you.
Okay, very thorough description of PEP. Any questions? Question?
Hello. What if I have only one device and I lose the device? The other contact will send me encrypted messages that I can decipher.
Yeah, so if you lose one device and it's part of the device group, you first need to tell your device group that this device is now not trustworthy anymore. But then you mean also if you have one device and you lose the key on it, so you need to revoke your key and you don't have a revocation certificate, then people will still be using the old key to send you messages. That's true. So the only solution there, which we're also trying to implement, is to have I lost my device function, where your last contacts, whatever defined, maybe you can define it yourself, just get a message with the new key, which at least with PEP users won't be even visible. So we send, similar to this key sync messages, those IMAP messages which aren't visible, then the new key to all your contacts, like the recent ones you've been talking to, the ones you've been mostly talking to, the ones you clicked yourself, and they get a key. If the receiver of that key isn't a PEP user, then the email will contain something like, hi, I lost my device and here's my new key. So then that user also knows what this is about. But yes, generally this is a problem, but we're trying to solve it that way.
Thank you.
Okay, thanks. More questions in the room? Okay, thanks, Otro bit
There
again.
was one.
Oh, another question.
Sorry.
Why am I speaking Spanish now?
I'm not sure that I understood all the whole presentation, but I'm going to the user side. And let's say that I have PGP, and another colleague of mine has a SMIME. Can we both have PEP and communicate securely?
Yeah, PEP can reply on SMIME, but won't do it like by itself.
Okay, thank you.
Okay, thanks.
I'm also here for the whole evening, so thanks.
Okay, well, we're going to take a very, very quick break. Thank you very much again.